Hey everyone, I am Ashish and today we are going to talk about data science. So, if you go to Google, this is the definition you will find out there. Like it's a field of study where you extract meaningful insights from your data for your business perspective, or depending on the website, there are different definitions for it. But what's the simple essence of it? So, simple essence is like if you have some kind of data. Of course, if you want to make some kind of application, you need some kind of data. So if you have been given this kind of data, let's say this is a sample data I've taken from internet. So the point is, look at the data and look at the size of it. Like we have 20,641 rows of Excel file. uh, Manually going through each of these rows will be like a nightmare. And so what we do is we have the data. So we need some kind of summary to ease our work to so that we can understand the data itself. But without going through, reading all the 20,000 rows by yourself. So see, one parameter is latitude, longitude, and median house. So what this data is about is that we have data of different towns in California. So this is the second row is for a particular town which has this latitude and longitude location, the median housing age, total number of rooms in that particular town, total number of bedrooms, population of that town, how many number of households there are, median income of people, and this median income is now in the units of 10,000. So it's like 8.3 would mean like $83,000. And this is the median housing value. So this is 452,600, quite a lot, right? And then there's ocean proximity, like if it's nearby or it's near island or it's in mainland or it's near ocean. Those the categories were somewhere like this. Yeah. So you see there are different categories for this columns. So the point is we have 20,000 rows and really we don't want to read all of that. So one way is to interpret it. What we are going to do is we are just going to apply some basic principles of data science and first of all visualize this entire thing like what this data is. So I have made a very simple geographical plot over here, which says density versus the house value, density of our town. So individually, all these markers, no, these are the towns. So the bigger the marker is, the more the population of that particular town is. And as you can see, the label, or you can say legend over here, you will see that the legend goes from the blue color to the red color, and red would signify, as you can see, more house value. So, one thing I would like to clear is that this is the ocean part, and I should have made it blue, but in the interest of time, I just kept it white. But anyway, this is the ocean. This black line is the coastline, and this is the map of California. So, one thing we can right away notice is that all the houses that are near the coastline, not all, but most of the houses that are near the coastline are either green or you can see all the red houses at least are near the coastline. So one insight you can drive away from this visualization would be that houses that are near coastline tends to be expensive. And take a look at this. These two data points. These are the expensive houses, but I believe it's an island, very much near to the coastline. It might be an island as well. And the second insight would be the more away you move from the coastline, you will see the values of the house pricing decrease. As you can see, these are the blue data points, and blue meaning that not so expensive houses in the range of $100,000. So just by making a visualization, we have extracted so much information about our data itself. Of course, we don't have the specifics of individual location, like if you were to point out to individual location, what's the specifics of it, of course. But for that, we can make different visualizations as well. But now that we have a basic understanding of the data frame itself, this was the data. And I call it data frame because when we import it into Python, we call it data frame because we have pandas data frames over there. Anyway, coming to the point, first thing we did was we had 20,000 rows. And to summarize it and to understand it, we just made one visualization. And of course, at this stage, it's better to read, to read 20,000 rows. It's just better to visualize it. They say that a picture is worth 1,000 words, and this is a very beautiful example of it. And now let's come to data science, and there are two associated fields to it. One is artificial intelligence, one another is machine learning. And when average human things of artificial intelligence, they imagine like robots walking around and taking over the world, but that's very far fetched from the reality. Anyway, We are going to talk about AI and machine learning with the context of data science. So, AI, as we imagine, is you can say intelligence, some kind of intelligence which computers have. So, what is that intelligence? So, to drive away that point, I have made this very simple app, and what this app is doing is basically it's reading through all these features and it's predicting the median house value of one particular town. So what it means is it this application has read through the entire training data, which is the CSV file over here, and what it says, if you tell me the location of the house, which is latitude and location, this latitude and longitude location, and if you tell me how old the median housing age of a house within that particular town and number of rooms, bedrooms, people residing, population, and so on, if you tell me all of these features, I can tell you how how much your dream house would cost in that area, right? So as you can see, these are the features, same from the data itself: latitude, longitude, housing age, total rooms, and so on. And this is our target variable. What we are going to do is we are going to predict median house value based on all the other features. Like if that particular town is near bay, near ocean, or if it's an island, or if it's a mainland, and we're going to predict based on all those features the house value of that town, median house value, like more or less the average of it. Median and mean are central tendency of the data, meaning if you give it an array of, like, let's say 100 values, mean would be the average of it and median would be the 50th percentile, the value that sits between the lowest and the highest value of that array. And given these features, look at the prediction that our machine learning model is making right now. So if let's take a look at this thing. Median income for household. It may signify something like rich people versus not so rich people. So 3.07, I believe it's in the units of 10,000. So 3.07 would mean something like $30,000 of 30,000. Should it be? It was 10,000 now. Yeah. So yeah, let's say it's 30,000 and anyway, the point is, if you change the value of this, if there are rich people in the vicinity, you see the prediction. It's more close to now 400,000. If you decrease this value right here, and you will see the prediction change. The point is, this application knows that according to which sets of features, how much it should output the value of your median house. It's a house price prediction app. Then again, if you tell it all these features, if the house is near island or near ocean and so on, how rich are the people in the vicinity, how many households there are in the town. Given all the features, this app can predict for you the value of the house that you are looking for in that particular geolocation. So at this point, you can this is what we have achieved over here is artificial intelligence. So what we say is that as long as our applications are doing something intelligent, they are giving out some human-like intelligence, exhibiting human-like intelligence. That's we say that okay, this is artificial intelligence. But then again, it's not magic. A lot of people think that this is magic. Yes, sometimes, not sometimes, but most of the times, these things, techniques like artificial intelligence, are very much useful to read through the data, giving us a brief summary of it, coming up with, we can come up with our own sets of problem statements, and AI basically we use to solve those problem statements. But the point is, it's not magic. So the essence of data science is that we are going to simplify it, right? So to simplify this, I'm gonna use a very simplistic example. So to drive that simplistic example point, I'm going to use a different example, which is something like this. You have data of three employees, and as you can see, in one column we have work experience, and in another we have salary. This is the data frame. You can imagine it's a sample data frame I just built over here. So as simple as that, we can visualize it, and you will see there are these 3 points: one, 1,000; two, 2,000; three, 3,000. Meaning that if the work experience is three, the respective salary is 3,000, and so on for two, 2,000, and one, 1,000. All right. So now let me pose a question over here. The question is, if the work experience is four, what do you expect their salary to be? So if the work experience is four, I mean, as a human, I can understand the pattern that it's a very linear, a straight pattern going upwards. So If the work experience is 4, then the expected salary should be 4,000, right? But we are humans. We can decipher these kind of patterns by looking at just the visuals itself. The point is, machines can do the same, but in a different way. And when they gave us the output, that we say that we have achieved artificial intelligence. But the way machines learn is through mathematics, and that is somewhere in the picture we say that that's machine learning. How machines learn through mathematics. That's the field of machine learning, and data science, machine learning, artificial intelligence. It's just one and the same thing. It's just that the context differs. When we have a intelligent output, we just call it in artificial intelligence. The way the machines learn, we call it machine learning, and the entire field of study of extracting something meaningful out of the data is called data science. But these three are more or less the same thing, but the way we use it is different. Anyway, the lingo is different, but means the same thing. Anyway, but if we were to draw a straight line through, like straight black line through all these data points, just like this, you would understand right away that this black line is following the same pattern, isn't it? So as humans, we were able to capture the pattern with just the three dots, but machines are not able to do so. But what if machines were able to understand this line? So given this line, if I were to ask the question, like what's the value of salary if the work experience is 4, then if you have this line, you can follow the dots, green to red and red to blue. You will reach 4,000, 4,000. Anyway, the point would be, let me just write this entire thing using mathematics, and you will see that we will achieve artificial intelligence in one way or another. It will be very simplistic, but that's the essence of it. So the example was something like this. See, this is a very basic example. I know, I understand that, but as long as you understand what this example is, let me tell you that this is the essence of artificial intelligence. This straight line connects the entire field of study to a deep learning as well. Because in deep learning, when we say we have a neuron, we have different hidden layers and this and that, and so many complexity. Everything just starts with a simple straight line equation. Anyway, the point is, we saw that line equation is able to solve our problem statement. But what if I were to write it very simplistically this way? That salary equals to some kind of value. Let's for the sake of simplicity call it 1,000, and work experience. So if I were to give it this mathematical equation, salary equals 1,000 times work experience. Now you can use any kind of work experience over here. Let's say two. Two multiplied by 1,000, it will give you 2,000. And what was it on the left hand side? Wasn't it salary? So see, the point is, we humans were able to decipher the 2,000 kind of thing, kind of pattern by just looking through a visual, but machines are not able to do so. So for that, what we do is we use some kind of mathematics so that machines are able to also identify that kind of pattern. Now, using the same equation of 1,000 times work experience, we could have just, gone ahead and say work experience is 5, multiply it by 1,000, and you will achieve the 7, which is 5,000 over here. 5,000. Let's go back to the same line and see, does 5,000 look correct or not? So 5, of course, 5,000. The point is, as long as you can define the entire world through mathematics, you can achieve you can achieve your artificial intelligence. And I don't know about you, but I like to keep things simple. Yes, the point is, learn, dive deep into the basics of things, know the things fundamentally well, but then try to simplify every of the problem statement. That's usually the workflow of things. So even though they are very hardcore deep learning algorithms, yeah, you always start your data science workflow using just very simplistic regression equations. And this is line equation. I just use the term regression, but essentially it's just a line equation. Now the point is, of course, if I already have the value of 1,000, now I can make this kind of equation. But initially, when we looked at it, we didn't have the 1,000. Where this term came from? So to find that, let's go back to the same image. And let's see, we know that, okay, we have identified the pattern as straight line. Now, machines can do the same, but how are machines able to learn this pattern? Now, it's not that the right away in the first step, machines will figure out that this black line is going through the data parts. No, it doesn't happen that way. So what happens is, that computers usually start with these four methods, which we will talk about in a while. Should the time allow us, we can talk about it. So there is a hypothesis. We write the hypothesis of how we define our mathematical world space. So in this case, we defined our mathematical world space by using the equation of y equals ax plus b or mx plus c. Same thing. What we did was related salary to the work experience, and a and b are just the hyperparameters which we can tune and change according to our needs. To be more specific, these are not hyperparameters; these are trainable parameters. Anyway, then we have some kind of cost. Cost meaning that if our predictions are correct, cost should be low, the error should be low. And if our predictions that the model is making are incorrect, then the error or the cost function should be high. So we'll break down this cost function as well should the time allow us. Anyway, to get started, what machines do is, see, we had the three dots. Machines will start with a random straight line. And then what they will do is they will calculate the error after that. So we already know the actual values are 1000, 2000, 3000. But the line, this black line, is now making the predictions of 0, 0, 0. It's saying that no matter the value of x, the salary is 0, which is kind of stupid. But it could be. Machines start with this way. So to drive away the point, let me write the mathematics of it. The equation at this stage is going something like salary equals 0 times your x variable, which was work experience. So let me just write it this way. Y equals mx plus c. And c in this case, I'm choosing to be 0 to simplify the entire thing. So I'm just writing the entire thing as y equals mx. Where m is our this hyperparameter, not hyperparameter, but it's technically trainable parameter. And y is salary, and x is synonymous to work experience. So anyway, what happens is we have usually random values of m. We take a random value of m, we try to fit it, and then we try to evaluate the cost. Like let's see, we have y right here. Let's assume that our m initially was something like m equals 0. Then the equation would have been y equals 0. And y equals 0 equation can be visualized using this kind of line, the black line, which is laying completely horizontal, meaning that no matter the value of x, the y value is still 0. No matter the value of your experience, the salary in dollars is always 0, which is kind of stupid to think. But the point is, we are not at the stage, making predictions. We are at the stage where we are evaluating the cost, how much error my model is making, and how the model training process is going on. That's what we are after at this stage. So you see these yellow lines, one yellow line, two yellow line, three yellow line. This is the difference from the actual value to the predicted value. These green points are the predictions, right, made by this black line. So at this stage, we can say that our machine learning model was following the equation of y equals 0 x plus 0. You can see that this is m and this is c. I'm using c as 0 just to simplify, but I will keep on changing m. Anyway, we use the value of y equals 0x, came to some kind of error, evaluate the error. So let's evaluate the error as well at this stage. The error would be prediction minus 0, take the whole square. Prediction 1 minus actual 1, take the whole square, and so on. There's a mathematical formula, and you will calculate some kind of error. And then we will say that the next line we are going to make it with would be the y equals 2000x with a equals 2000 and b equals 0, which would visualize something like this. And then again, you will calculate the same error, the distance between green and this violet data point. Add those errors up, and you will come to some kind of error. And the point would be, as humans, you were able to identify this black line right away, but machines are not able to do so right away. Machines tend to make a random prediction first, and then they will calculate the error. And then the objective is decrease that error step by step. So in this case, initially the line was made like this. Then another random set of data points of m. So will lead you to a different kind of equation, a different m, a different equation, a different equation, a different visualization, a different visualization, a different cost, or you can imagine the cost function or error. So what you want to do is right now at this stage, I want to minimize this error. So you will see that in individually, as I move forward, now machines will try to learn where the error is getting minimized. So at this stage, another random line I have drawn, not me, but the model has drawn, and you will see the error decrease to 500,000. Initially, it was 2.3 billion, I believe. Yeah, initially it was 2.3 million. Now the error has been reduced to 500,000. Now another set of line which is we are using at this stage y equals 1500x, and the error will change again, and then so on. This process keeps on repeating till we achieve the minimum error. And when we finally evaluate or visualize the error versus the value of trainable parameter A, my mistake, it's not hyperparameters, it's a trainable parameter. But then again, when we plot it this way, what we realize is that there exists a value of a trainable parameter where the cost is the lowest. And over on the y-axis, I'm plotting the cost, which is mean square error at this stage. But anyway, we are discussing how to reduce this cost, how to reduce the error. And when we have reached the optimum value of the trainable parameters, which means we have reached the lowest error rate, optimum solution, and we record the value of that particular trainable parameter, which is 1000. And now let's go back to the initial equation 1000. Do you remember what this 1000 was? Wasn't it the same as the same thing we have been doing right here? Salary equals 1000 times work experience. It's the same equation, which gave us 1,000, 2,000, 3,000, 4,000 kind of patterns. So the point is that the way we learn a situation is very different from way computers learn. So it's not magic errors at the end, mathematics. And to be very specific, it's not. It doesn't happen this way. Like machine will make a random line every time, and wherever it sees the lowest cost, it will choose that. What happens is it makes a random line, records that observation, and tries to minimize it using something called gradient descent. But I don't want to go into that at this stage, at least. So the point is, why was I saying that this is the most important equation of machine learning in data science? That's the major point, right? So the major point is that as long as we understand the basic line equation, we can solve these tasks. Tasks of the kind where we made this app can be done using the line equation. All right. Then what else can we do with this task of this kind? Let's say computer vision. If you heard about face detection, biometrics detection, face recognition, instant segmentation, and stuff like that. So we can do that. But at the stage, you might be thinking like, how can a line equation be used in computer vision? So let me let me just start it this way. We were writing something like y equals mx plus c. What if I were to tell you that if I have a way of writing this in this way, like m multiplied by some kind of image plus c can tell you the person, maybe Dwayne Johnson or something like that. Dwayne Johnson, or maybe whatever it is. But see, the point is we can take this initial line equation and map it to images as well. Now you would ask me that image is a visualization, it's not a number. So what we do is we convert our visuals to numbers, and we will see like how it's done as well. But then again, we can make chatbots using the line equation as well. Chatbots, or you can say machine translation softwares, which would do something like if you have a string like this way. Let's not write it as y. Let's have a string. This is a good product. This is a good product. So you have the string, and I will use the same line equation of the kind y equals mx plus c. The only difference would be I need one way to map this string to some kind of numeric so that I can use the string data inside of a line equation, or not specifically line equation, but in I want to perform some kind of mathematical operation using the string. So that's where comes the concept of converting image or string data to your what do we say, mathematical form. And as we have seen, as long as we are dealing with something mathematics, numerical form, we can apply equations of the simplest kind, like mathematical equation of line equation, this y equals mx plus c, or we can just use very very advanced equations as well. But the point is, to use those mathematical equations, we need one way to represent the entire string into a vector form. So for that, we look at something like this. Now take a look. What do you see when you look at this image? It's an image of 3, the digit 3, right? this is how I can write it using a vectorized form or a numerical form. You can see the patterns that wherever the 3 is making, I'm writing 255. So the point is that image is nothing but a collection of pixel brightness values, and zero brightness meaning that the pixel is completely dark, and 255 of the brightness value meaning that the pixel is completely white. And as long as we have this kind of information, we can make the images, and we can convert the images to numerical form as well. So this is the digit 3, and if I were to write it this way, it's still the image of 3. And if I were to capture its numerical form, it would be something like this. This numerical form does not make sense to us humans, but this numerical form is how machines read the image data. And as long as we have the numbers, we can use these numbers to make our computer vision task, like face detection and stuff. And the point would be, I want to use these numbers in the equation of the kind y equals mx plus c. And we have then again achieved the artificial intelligence, and very simply as well. So the point is, I want to use this equation, not necessarily this equation, but there are advanced equations as well. The point is, this is a very simplistic example of how we convert images to some kind of numerics. And because, when we have numerics, we can essentially perform any kind of mathematical operation. And if we can perform mathematical equation, you will see the mathematical magic happening all the time. And when you see those computer vision tasks like self-driving cars and whatnot, all they do is analyze mathematical equations, analyze data through equations and whatnot, and they capture the ongoing footage from webcam, and they make their decisions accordingly. And how does that happen? So let me maybe try to show you the computer vision task, or maybe I'll hold off onto that. Let me come to the part where we look at some kind of string processing. See, you see sheet 1, sheet 2, sheet 3, and this is nothing but the segmentation using the mathematical equation, and this is called a bounding box. What not? See, let's not go into there. It would be deviating a lot on the original topic of discussion. Anyway, the second point was, I want to I want to encode this string into some kind of vectors or maybe numerics. I want one way to convert strings to mathematical data. So for that, we do have some kind of vectorizers and methods. But take a look. Initially, we had four sentences. Early to bed, early to rise makes a person healthy, wealthy, wise. Right? Now, I don't, I'm not going to go into the details of how I did it, but take a look at this. Essentially, what I've done over here is I've converted the vector, or I've converted the string of early to bed into a vector of 01100001000. So the point is, I have represented the string early to bed in a way that machine can understand through just zeros and ones, right? So, of course, this 0 and 1 does not make sense to you as humans, but it makes sense to the machine, although we have, lost the sequence of it. So the machine will be reading the string early to bed as bed early 2. You see, bed has 1, early has 1, and 2 has 1. So the machine will be reading the entire vector as bed early 2. We have lost the sequence, I admit, but at least we have successfully converted our string data to integer data. And when I say ASCII, I keep on saying the word string, string, string. This is what I mean when I say string. Textual data is called string in Python. So we needed one way to convert the textual data into some kind of mathematical representation so that we can apply the same basic mathematical equation of y equals mx plus c or any other advanced equation as well. The point is, I just wanted one way to convert the textual data to mathematical form so that we can mathematically analyze the strings, even though we are losing sequence in it. But we have still achieved the task of numerically representing the entire string data or textual data. Now, let's take one step forward and try to preserve sequence using bigrams. Bigrams meaning that not only I want to keep the count of the words, like how many times the words are occurring. So in this case, bed occurred one number of time, early occurred one number of time, and two occurred one number of time. That this was called vectorizer. Not only I want to count the number of words, but I want to count the number of the sequence of two words as well. That's called bigrams. So early two and two bed. I'm adding these two tokens as well. So there was the words as well, and wise, bed, early two. So you can see early two and two bed also been added to this thing. And because in our vocabulary we had early two and two rise, so you will see two rise token as well, and makes a person. So it should be right here somewhere. Makes makes a person. So makes person. Oh yeah, actually A is a stop word, so we have removed the stop word A. So it should be makes person. And healthy, wealthy, and wise should be like healthy, wealthy. You will find something somewhere. Healthy, wealthy, right here. Wealthy, wise should be somewhere as well. Yeah, wealthy and you get the gist now. What's going on is we are trying to preserve the sequence of two consecutive uh, words. And moving forward, the point is that initially we had the text data, and now we ended up with its numerical representation. And as long as we have the data in a mathematical format, we can just simply use the equation of y equals mx plus c or a different advanced equation. And as long as we can use the mathematics, we can achieve the magic of artificial intelligence. With that said, we have achieved computer vision, we have achieved natural language processing, and when I say natural language processing, it could be machine translation of one language to another, it could be chatbot, chat GPT, I'm sure a lot of you have already heard. So let me conclude my case by simply going back to the simple app that I have made over here. The point would be that data science was the study where we were analyzing our data, maybe some kind of textual data, maybe some kind of image data, maybe we are doing the exploratory data analysis just to understand the data itself. That's data science, the entire pipeline. How the machines were learning in the behind the curtains kind of thing. That was machine learning. How a machine basically learns to find the pattern. How a machine learns to where to draw the line through the data. That's machine learning. And the output that we achieve, intelligent output that we have right here, that's in a nutshell, we say this is artificial intelligence. So I hope you like this session and let me close it now. Thank you.